Some potential photovoltaic problems that could exist. Most solar PV systems are implemented safely and dependably by certified and respected experts. However, having an untrained person install a PV electric power system can be problematic. The following are a few of the frequent issues with the design, setup, and operation of PV systems. PV array is heavily shaded. Unstable structural attachment to buildings and other surfaces. Roof penetrations and other openings lack proper weather sealing. Dangerous wiring. Unsafe battery installation, poor battery care, or incorrect battery use. Insufficient conductor ampacity and/or a poor type of insulation. Utilizing unspecified equipment. Applying listed or unlisted equipment incorrectly. Overcurrent protection and disconnect devices not being placed correctly. A bad grounding of the system. Major system components and disconnect devices don't have suitable labels. Insufficient documenting of system requirements for operation and maintenance. For some system components, environmental protection is insufficient. Testing and troubleshooting. Supporting documentation is required for every photovoltaic system design package, and it must at the very least comprise system specifications, electrical schematics, mechanical drawings, component lists, materials lists, and source lists. As well as describing the necessary tools and equipment, documentation should also include installation and checkout methods, user and operator training, maintenance needs, and troubleshooting manuals. Depending on the equipment used and the type of system architecture, solar systems may require different levels of maintenance. Some setups may only need yearly inspections and very minimal maintenance. Others, especially those that use batteries, might need 4 to 6 monthly maintenance checks or even periodic replacements of individual parts, often batteries. PV installations commonly need the following maintenance. Examining electrical connections and terminations for corrosion and looseness. Verifying that wiring harnesses are securely coiled and packaged by looking at them. Verifying the PV array's cleanliness, damage-free status, and structural soundness. Examining roof penetrations and weather sealing. Battery maintenance may involve cleaning, adding electrolytes, adjusting the charge, and replacing the batteries as necessary. Use the right equipment for the job. Use the proper tools for the job whether you are building or maintaining a PV system. A high-quality digital multimeter with an amp clamp or a clamp meter with voltage measurement capability is typically sufficient for the majority of operations involving the PV modules and their accompanying DC circuits. When receiving and again after installation, test modules using a clamp meter or a digital multimeter with an amp clamp. Check the output voltage and current of an array using one of these instruments. Make sure the right devices are linked in series during installation to deliver the right voltage. For the proper current to flow, make sure the series array portions are linked in parallel. To check the inverter's connections, input and output voltages, and current, use a digital multimeter and clamp meter. As you would with any other AC power system, these tools can also assist you in troubleshooting the remaining components of the installation. Oscilloscopes or scope meter combos are necessary for some inverter issues. Use an oscilloscope, for instance, to spot and pinpoint noise issues in control circuit windings, or to confirm that insulated gate bipolar transistors are operating correctly by looking at their waveforms. By using a scope to measure across the transistor, you can find a shorted transistor. The waveform of a good transistor is a neatly formed square wave with sharp edges, while the waveform of a defective transistor has a softened leading edge peak. Make sure the waveform at the inverter output resembles a sine wave as well. There may be some harmonic content on the AC coming from the PV system because almost every PV installation employs inverters to convert the DC from the PV array to AC. The main culprits for harmonic production are variable frequency drives, VFDs. The VFD circuits that produce harmonic currents are infamously similar to the circuits that inverters utilize to convert DC to AC. Typically, harmonics should be minimized in PV system designs. However, you can utilize a power quality analyzer to examine the system if you think your facility has harmonics issues. You may get a photovoltaic system going safely and reliably and maintain it running safely and reliably by being aware of potential issues, testing, and troubleshooting with tools appropriate for the task at hand. The PV panels, load, inverter, and combiner boxes are the four components of a PV system that are often the focus of troubleshooting. Draw a diagram of each branch's wiring going backward from the concentrator. Visually inspect the entire system for any noticeable blemishes or unintentional disconnections. Check all cables, switches, fuses, and circuit breakers after you've located the problematic module or array. Fuse replacement, breaker reset, and switch resetting. Make sure there are no loose or dirty connections or broken wires, and replace or clean as necessary. Observe the connections between the modules for any loose ones. They might have labored carelessly and prevented interaction.